Okay, in this lesson we're going to talk about compound interest, which is similar to simple interest but has a little more to it. So before I go through all the definitions on your handout, I want to go down to the bottom of the first page here and just look at example 1. And that'll help us understand the difference between simple interest and compound interest. So show the difference in the amount of money earned using both simple and compound interest for investment of $10,000 at 5% per annum. So remember that means per year over 3 years. Okay, so let's start by looking at simple interest, which we've already done. So we'll just do this quickly so we can see that again. So here's how it goes. You start with $10,000. So let's find out how much we have at the end of year 1. So year 0, you'd have 10,000. I'm just going to skip that and go right to year 1. All right, so it's 5%, right? So 0.05, that's 5%. We're going to multiply that by the amount of money, $10,000. And when we do that, we're going to earn $500 interest, right? So how much do we have at the end of the first year? We'll put a little total column here. Okay, so if we take that $500, add it to our $10,000, at the end of the first year, we have $10,500. All right, year 2. Right? It's the exact same thing. You get 5% again times $10,000, right? That gives us another $500. Let's add that to our total. So 10,500 plus another 500 is 11,000. And year 3, right? Same thing. 5% times 10,000, okay? Gives me another $500. We just add it to the total and we have $11,500. So that is our final amount at the end of the third year. So that's simple interest, right? So the interest never changes with simple interest, right? It stays the same. So even if we kept earning interest for 100 years, every year we'd earn $500. All right, now let's look at what's called compound interest. And when you think of the word compound, compound means to put things together, like a compound word, right? Is putting two words together to create a new word. So compound interest is basically when you put interest with interest. So let's show you what that means. So year 1 starts out exactly the same, okay? It's still 5%. We're going to times it by $10,000, right? It's going to give us $500. We add it to the total. We have $10,500 at the end of the first year. Now here's where things change. Second year. All right, year 2, it's 5%, but we don't times it by 10,000. What we times it by is the $10,500. So we take that amount of money and we are going to multiply it by 5%. So what they say here is the interest has been compounded. It's been put together with the principal, with the starting amount. We've added it together. So now we get 5% on the principal and 5% on the interest. So when I multiply that, we're going to get $525 interest in our next year. So let's add that to our total, and we have $11,025, right? All right, year 3, same idea. It's 5% again, right? 5%. Again, we don't times it by 10,000. We times it by the total. So what happens is at the end of the year, they take the interest, the $525, they add it to the total, and then we get to find interest for the next year on that total amount. So we get to keep putting the total in there. So we're going to times that by $11,025, and when we do that, we're going to get $551.25. So notice every year the amount of interest I get is increasing. So at the end of 3 years, we have $11,576.25. So notice how we made $76.25 more than the simple interest, which might not seem like a big deal, but what if you're investing more money? What if you, we're investing for longer at a higher interest rate? It really grows quickly. So the difference here, you basically are going to pay or earn less money with simple interest. So obviously with simple interest, if you're paying someone to borrow more money, you want simple because you're going to owe them less interest. But if you are earning money, you want compound because you're going to earn more interest. So that's less money versus more money. So let me just write out something here. I'll pause and write. Okay, so again, with simple interest, you earn less money, right? You only get interest on the principal. So it never changes. It's always $500 because we're always finding 5% on $10,000, right? With compound interest, you're going to earn or owe more money because you earn or pay interest. I wrote earn here, but also pay or owe interest, right? On the principal and the previous interest. So notice how we earn more. So that's the difference. Now, it's a pain to have to write it out and do it this way. So obviously we're repeating something here. There's a pattern to it. There's a formula. So let's go up and take a look at that. Okay, so I've got our definitions here again. Let's just look at the key ones here. Principal. Remember, principal is like the starting amount of money, how much you start with. So it could be how much you borrow or how much you invest, depending on whether you're the person borrowing the money or you're the person lending the money, okay? The amount, which they call it, is the end amount, is really what they mean. How much do we have at the end? And again, it could be us investing or borrowing, right? So again, the starting amount is the principal. The future amount is another way to look at it. I like those terms, the starting and future, okay? All right, so now interest, that's the money that we earn from our borrowing, the cost of borrowing money or investing the money. Simple interest we've already talked about, so let's just review compound interest one more time. Again, this is interest that is added to the principal before new interest is calculated, like we did in that table below, right? We would add it and then calculate the new interest. So interest is calculated on the principal and on the interest already earned. So interest is paid at regular intervals called compounding periods. So this is something we'll have to pay attention to as we do these, okay? So far, everything has been per year, right? But what if it was, so this means when we say compounding periods, we mean how often is the interest added to your account, okay? Or how often is interest added to the amount of money you're borrowing? So down in our example here, it was every year, right? At the end of every year, we'd add the interest in. But there's different ways. One of the most common is monthly, right? Every month the interest is added in. So they do it 12 times per year. But you can also run into quarterly, semi-annually, annually, things like that, okay? So keep that in mind. We're going to need that when we're figuring these out. So let's check out this formula. A, again, is our future value. That's the amount. P is the principal. We go 1 plus I. For some reason, all the textbooks like to use I for the interest rate here, but they use R for the rate when we're doing simple interest. I don't know why we can't just stick with one letter. It drives me nuts. But there you go. Now, how do we calculate the interest rate? Before, we just used the rate. So like if it was like 5%, we just make it 0.05, right? But now we have to divide it by the number of compounding periods, I should include in here, per year. So let's say we were doing it monthly, 12 times per year. What we have to do is take that 0.05 and divide it by 12. So what would we get if we do that? Let's see. I would get a pretty tiny decimal here, and we don't want to round this off. I'd get 0.00416 repeating, okay? So whatever that compounding period, is it 12 times, is it quarterly, 4 times, semi-annually, or biannually, twice? If it's annually, we just divide it by 1. So in other words, 5% divided by 1 is still 5%, okay? And the final thing here is the number of compounding periods that occur. So we got to be careful. So generally what you have to do with this, in most cases, is you have to take the number of years that you're going to be investing or borrowing the money, okay? And you are going to multiply that by the number of compounding periods per year. So what that means, let me just get this down, compounding periods per year. All right, so what does that mean? Number of compounding periods. So let's say you invest for 5 years, and let's do 5 years. That's kind of getting confusing with the 5%. Let's just say it's 4 years, okay? Let me just undo that there. All right, so let's say it was 4 years, and we'll see these when we do the questions. So if it's 4 years, right, I'm going to be investing, and let's say it was monthly again. That's 12 times a year, so I'd have to times that by 12. So 4 times 12 means there would be 48 compounding periods. It would happen 48 times, right? Because every year, 12 times 4 years. So those are the little calculations we got to do when you do these. All right, so let's try out some real examples. You're not going to have to sit there and write these out like I did down here, hand by, 1 year at a time. We want to use this formula here. So pay attention to this formula. This is the one we're going to be using here, okay, for all our questions today. Okay, so what we should do when we're doing this is write down along the side our variables and then show what they're going to be. Because when we do this on a test, this is generally what I expect you to do. Write them down. What's A, what's P, what's I, and what's N equal to. All right, so it says we are investing. Now this is going to be, these first two are going to be when we're determining the future value. We'll talk about determining the past value in the next couple questions. So I'm investing $7,000. That's what I'm starting with. $7,000, right? Now, whether I'm borrowing or investing, it doesn't matter. Compounded at 4% per annum, okay, so 4%, compounded monthly. So we need to take the interest rate and divide it by 12. So 4% is 0.04 divided by 12. Now, if you want to make that a decimal right away, go ahead. I just leave it like that, and then I do it when I get to my formula. All right, now, N represents the number of compounding periods. We're doing this for 5 years. So 5 years, but they're going to add the interest onto this loan or this investment 12 times each year because it's compounded monthly. So we have to multiply by 12. So that's going to be 60. All right, so pretty easy for this first one. So what we're looking for is, what is the value after 5 years? What's it going to be worth? All right, so A equals P times 1 plus I to the power of N. So we just got to substitute everything in here. What's $7,000 times 1 plus the interest rate? So when we're doing this in our calculator, the first thing we want to do is go 0.04 divided by 12. We're going to add 1 to it, and we're going to get that decimal. Then we're going to do that to the power of 60, right, because that's what N is. Once we have that number, times it by 7,000. And I already got it calculated here, so I've got the amount at the end is approximately $8,546.98. Cool. So that's our final answer. All right, now, another question that comes up a lot will be how much interest was earned. So it's pretty easy to calculate the interest because if we take that formula, remember the interest we have, okay, let me just do that in a different color here. The interest we get is if we take the amount and just subtract the principal. How much did we end up at the end with? So basically you're saying take the end amount, subtract the starting amount. So the interest we get, let me just write this down here. The interest earned. So I want to calculate that for each question too that comes up here. All right, how much interest was earned? A minus P, what's 8,546.98 minus the $7,000 they originally invested, right? It's gone up by $1,546.98. So that's how much they got for investing their money. Okay? All right, let's check the one next to it here. Example 3, another one we're determining future value. So let's start by just writing down everything. Now again, I know this is compound interest. It says compounded. That's the key. It doesn't say anything about simple interest. The simple interest ones will say simple interest. The compounding ones will say how often they're compounded, okay? So that's the difference. All right, so you borrow $65,000. So it's set up the same, whether I'm borrowing or I'm loaning the money or I'm investing it. That's the starting amount to go to university, right? Okay, 5.8% interest per annum, compounded quarterly. So 5.8% is 0.058 divided by 4, right? So we can calculate that or just leave it like that. I'm just going to leave it like that and calculate it later. What do you owe after 10 years? Okay, so take the number of years, which is 10, times it by how many compounding periods are there in a year. Quarterly means 4 times a year. So we multiply that, we're going to have 40 compounding periods. So again, the compounding period is how often they add the interest to your bank account and then calculate the new interest on the total. So we're going to do that 40 times. All right, so here's our formula. Principal times 1 plus the interest rate to the power of n, which is our number of compounding periods. Okay, so what's 65,000 times 1 plus 0.058 divided by 4 to the power of 40. So do this first, 0.058 divided by 4, add 1 to it, do that to the power of 40, and then we times that by 65,000, and we end up with $115,610.00 when you round it. All right, so that's how much you owe the bank back, right? You've borrowed it 10 years later. They come calling. That's how much money they want from you, right? So again, to calculate the interest that we earned, the interest is just what is the amount that you end with minus the starting amount, right? So what is $1,115,610 minus $65,000? When you subtract that, you get approximately $50,610. So you're going to have to pay the bank $50,000, over $50,000 to borrow $65,000. Plus you got to pay that $65,000 back, right? So we got to be really careful when we take out loans for school and stuff because nobody thinks down the road. Everyone thinks, I'll figure it out. I'll graduate. I'll get a great job. I'll pay it off in like no time. And it is a scary reality, and I've seen it everywhere in my life and experienced it to some degree myself and my family life, right? Having this loan loom over your head and linger over your head for years, okay? All right, let's check out 2 more. Okay, so these last 2 are present value questions. In other words, we know the end amount, we want to know the starting amount. So we just got to move things around a little bit, rearrange our formula or equation a bit, right? So let's write our variables out here along the side, and let's see what we got. Okay, after 10 years, so I know it's going to be a 10-year investment, right? An investment is worth $24,000. So I know this is the end because it says after 10 years, at the end. So that's the end amount, $24,000. All right. It earns 7.3% interest per annum, compounded semi-annually. Now again, the interest rate is always per annum, and then what's it compounded, right? Per year, how many times are they compounded in that year? So semi-annually means twice a year. So what we're going to have to do is take that interest rate, 0.073, and divide it by 2. And I'll just leave it as a fraction again. And we got to do the number of years. 10 years they invested it, and 2 times a year they added the interest to the account. So they call that the compounding part. Remember, why they call it compounding? Because they're taking the amount of money you have, they're adding the interest to it. Compounding means to put together. So it's just a fancy way of saying adding the interest to the amount of money you have. So that means they did it 20 times. 20 times they added the interest in. What did they start with, right? How much was invested? How much was the starting amount? Okay, so here we go. Now, we can just do it this way if you want. We want to isolate P, right? So how are we going to isolate P? Why don't we just divide by this entire number here, this bracket with to the power of n, right? So in other words, if I just flip this around and divide both sides by 1 plus I to the power of the n, I'll end up with a over 1 plus I to the power of n. There you go. P is isolated. That's all it takes, right? So what did we start with? $24,000, right? Divided by now instead of multiplied by 1 plus 0.073 divided by 2 to the power of 20. So now you got to be careful here. What you're going to want to do probably, if it were me, I do this first, 0.073 divided by 2. Then I would add 1 to it. Then I do it to the power of 20. Then I take my calculator and go, what's 24,000 divided by my previous answer using that button on my calculator, and I'd get my answer. And we're going to end up with 117,017. There you go. Wait, do I got that right? Hang on, do I got the right amount of numbers? Yeah. $117,017.23. There we go. That's the approximate amount we end with. Or started with, right? That's our starting amount. So how do we find the interest earned here? It's the same idea, right? How much interest was earned? All right. We just need to subtract from the end amount the starting amount. So interest is always the end amount, which is A, minus the starting amount, your principal. So we already knew the end amount to start. What's 24,000? Right? Minus 117,1723. Right? And you subtract those and you're going to get the amount of interest you earned was $12,282.77. So hopefully you're starting to get an appreciation now for the phrase, money makes money, right? You got to have money to make money. This is how a lot of people make money, right? Investing money, investing in different things, the stock market, different stuff too. But the idea of taking your money and investing it, and it makes money for you, right? All right, last one here. Determining the present value again. You need a loan. You want to repay it in 5 years. You don't want to owe more than $30,000. The bank will loan you the money at 8.5% compounded quarterly. How much can you borrow now? How much interest will you pay? So this sounds different. It's the exact same thing, I think, as the last question. Let's check it out. Last one. See if there's any catches in this one. All right, so we want to borrow $30,000. Or no, we don't. It's not that we don't want to borrow $30,000. My bad. We want to make sure at the end we don't owe more than $30,000. So that's our end amount, right? At the end, we want to make sure we don't have anything more than that. So we'll set A to 30,000. The principal. All right, that's what we're looking for. How much can I borrow right now, right? Okay, interest rate 8.5%, so 0.085 divided by what do we got? What are we paying here? Quarterly. So 4 times a year, right? They add the interest. But we got to break that interest for the year into 4 quarters. That's why you divide it by 4. And the number of periods, well, it's going to be for 5 years, and they're going to add interest quarterly, so 5 times 4 is 20. So this is the same thing as the previous question, right? Here's your formula. I can just quickly rearrange it by dividing both sides, right, by this bracket, right? That's all I'm doing, dividing both sides by this bracket. And from there, we can just isolate P. Oops. All right, so I'm just going to flip it around and go P now equals A divided by 1 plus I to the power of n. So your principal that we need to solve for, the starting amount, is $30,000 divided by 1 plus 0.085 divided by 4 to the power of 20. So divide the 0.085, divide that by 4, add it to 1, the power of 20, and then take 30,000, divide by that number, and you should get $19,700.62. So in other words, this person shouldn't borrow more than $19,700. If they do, they're going to owe more than 30% or $30,000 at the end. And then interest is the same as all of them. I've just been doing it for all of them because it comes up so often. It's just how much did you end with? How much did you start with, right? So what is $30,000, which is what we are going to end with, minus $19,700.62. In other words, the interest you'll owe the bank is $10,299.38 for borrowing that money. So remember, you owe them the interest plus the $19,700 that you borrowed, right? So you got to pay that back plus interest. All right, so try today's questions. They're pretty short. Make sure you show your work like this. You don't have to show every step of your formula like I did. Let's just kind of point out what you got to do. You know, substitute all your numbers in like I did here, you know, in these kind of questions. Show me that. Show me the formula you're using, right? So show me what you're using. Basically, show the steps I showed, right? Show me along the side what each of these variables is. Show me the interest earned or paid. Okay, so basically if you follow and show exactly what I showed here, you're good. You don't have to show every calculation because you can just go to your calculator and punch this stuff in. All right, thanks.